Yeah, Henri Terho is from Copado. He was also a speaker at our test challenge last year, and we finally met last month in Berlin uh, uh, at our jubileum, at our birthday, at our 25th birthday. So I'm more than happy that you could make it, Henry. And I'm very excited about your talk about making test automation act human, testing with machine vision. And the stage is yours.
Okay, thank you. Thank you for having me. And actually, as I said, we met the 50-year anniversary of ASQF, and we are also next week going to be in Agile Testing Days in Potsdam. If anybody's around there, you can come meet me and the other guys from Copado as well. So we'll be there. And then I noticed that I have 1.5 hour slot to talk. I'm not going to use 1.5 hours of your guys' time. I'm guessing this is going to take about 45 minutes and then Q&A, and if you can get a good discussion going after that, I think that's the schedule that I think we'll go in. So who am I? I'm Henry. That's actually the old title. I'm a product evangelist now, but I used to be the chief R&D evangelist at Sentinel. So we were a smaller Finnish company, testing company, and test consultancy company called Sentinel previously. We are actually the company who developed Robot Framework and then open sourced it. So we have a lot of history on that side as well on test automation. And now we're bought by this US company called Copado, which is also focusing a little bit more on DevOps, but they really want to keep our testing tool alive as well. I'm doing a PhD in software startups, and that kind of caught me into testing and quality analytics as we were kind of talking about what's the quality of software development in startups and all of these other things. And there really weren't that kind of tools that you could use to get a lot of information on what startups are actually doing with their software development. So I ended up developing those, and through that channel ended up at Sentinel and being here ever since, and talking about testing, talking about quality, talking about what do we actually want to achieve with software and what do we want to do with it. Is that something that's testing is also deeply ingrained in, that testing kind of tries to verify that your software is doing what you actually want to do it about. And I think that's a big theme in today's talk that I have is how do we make sure that software behaves in a way that we want to, not that the code is correct in a sense. Just quick topics on there is why do we even test things is something, and talking about the whole testing paradigm, and then talking about a little how that's gonna I think change a little bit now with a lot of machine learning support and machine vision and these other tools, and what kind of tools are actually enabling that change to happen, and how is that proceeding in there. One thing is that topic that's happening, a big change, I guess, in the software environment as well as the rise of low code, and this has been talked a lot in many circles. What does this even mean, or is this kind of like a risk for software developers and software development, that everybody's taking into use tools that use drag and drop editors to generate code and all of that? And I think this is a big change that's happening in the software industry at large, or maybe the better way of saying it, that this change is happening outside the software industry, that many companies who previously wouldn't have, for example, built their own applications by themselves are starting to do that. We can see it on RPA, for example. Many of you guys, if you've done RPA, you kind of know that it's just, well, bad programming in some cases, that with platforms that don't have APIs of that, so you have to go through the UI. But that is kind of one of the points that kind of shows that this whole software industry game is changing a lot, and a lot of these low-code platforms are coming into the air, which are actually generating code. So you cannot really, because the code starts to be more and more of a black box environment in a sense, and you haven't really generated it yourself, or your team hasn't really built it, or something like that. How do you test these kind of platforms in a sensible way, and how do you actually build that kind of capabilities into testing tools, and how does this impact to testing as a whole and as a business. And I think that's a really interesting thing that's happening, that we are slowly building up better tools on a higher abstraction level. And this is going to, I think, affect the testing pyramid quite a lot. Typically, I don't know how many, I think most of you guys, if you're in testing, you're pretty much familiar with the idea of a testing pyramid, that it's if you want to test everything and figure out that everything works the way you can, well, of course, the easiest way is to read through every single code line and check that it actually does what you expect it to do, and do the review steps. But you have to just have a huge amount of that time to put into that, and it's quite expensive. And that kind of gives you the baseline that you can actually just review everything and understand everything, and then you know how your software works. On top of that, you have the static tests, which then slowly start building up abstraction layers on top of the code base. You have unit tests testing single stuff in there, how those interact with each other, and on top of that, you have the acceptance tests on how the system actually behaves, and what's the kind of human interaction level on there, that can we actually use it to the purposes that we were talking about. And now with this kind of like low code approach, I'm figuring out that the bottom layers of the testing pyramid are kind of very difficult to test, in a sense that you don't know what the code should be doing in that level. The gap between the acceptance testing and the actual features of the code and the software are super difficult to then go through all the abstraction levels and end up with the code, because it's typically machine generated, or it's starting to be more and more machine generated, and validating that is then not in the same the responsibility of the testers, but maybe the builders of the actual machines that build those kind of code. And the same principles, I guess, also apply to a lot of other software as well, not just low code. We nowadays use a huge amount of libraries to build any kind of software, and I think, like, even in our product, like 95% of the code is something that's been written outside of our company, and we are building a lot of stuff on top of external APIs which we do not control. So how do you keep control of this kind of software stack, where you have a lot of code from the outside, which you trust that they test themselves, and you kind of implicitly trust that those libraries work, but you never kind of be sure. And then the other way around, you build on top of APIs from other companies, which might change in time, which is not in sync with your, for example, your release pipeline, which kind of leads into this fact that more and more you're losing more and more control of your actual software pipeline on how you get the actual software end product. And it kind of forces you to become more maybe reactive, or continuously improving your actual testing tooling and how you actually doing that, which actually leads to, well, DevOps pretty much. How can you run a continuous testing process? Even in some places, for example, cars have typically been the domain where this doesn't happen. You have yearly releases and you have really controlled environments. But now with self-driving and all this other stuff, with non-deterministic code, well, we can debate if any code is actually non-deterministic, but kind of like the self-driving algorithms, all that, they are a really big problem on testing side. You cannot really verify those in the same way. And also when you start adding up or connecting the car to the environment, connecting sensors, connecting it to the internet, the whole software package and development of that starts approaching the same kind of continuous pipeline as it's happening in the web and web development as well. And I think on handling these three changes, we have to maintain really good flow. We have to maintain that feedback loop continuously from the development environment to the actual testers and developers, that we know what's happening in the environment and move with that and learn based on those. And those kind of things, while it quickly sounds like it wouldn't change that much because the bottom line disappears from there, it's actually something that it just keeps speeding up. If you think about it, you're going to need faster tools to actually test at the same pace. Kind of previously, when all the development was done on the hardware level, actually you had to build your own transistors and all of that to get your computer to do whatever you wanted it to do, and then it was quite easy to test that what happens in there and going through all the charts, all the components installed right, and build on that top of that. Now we have machine language, which can be built on top of like programmable processors that we have, or microcontrollers and all of that. And then back when C++ and the other C languages came out, they were saying that now this is the age of the new, much higher level abstraction tools where you don't have to handle memory. Well, you still have to handle memory allocation in C++ and all of that, but like you don't have to do all the nitty-gritty stuff yourself. It's much more higher level than actually assembler or machine language underneath it. And then on top of that, for example, scripting languages like Python happened. They said the same thing. We are taking more and more of that abstraction layer with us and building stuff and making you much more further from the actual hardware. And when you think about it, then on top of that, we have now a lot of these low-code code platforms and low-code test tools and all of this that's actually coming to be built on top of Python and other programming languages, which again raise the abstraction of your tools and actually make your tools much more expressive. It's much more easier to make a website open in Python than actually going to C or some other language to write the same stuff. You need a lot less expressive power, or that the Python has more expressive power in the language, so you don't have to write as much of it to get the same results. And this is like what's happening in the low code. You're relinquishing more and more control of the actual software systems out. And I guess where this is going is in the future is going to be more and more human-like interaction between your actual between the actual systems, where you actually might be talking to these computers and they are interpreting your message and what you're doing. I think my favorite thing is kind of figuring out what would be the best programming languages, which pretty much would be that I just go into a meeting room, start talking to the system that, hey, these are the kind of features that I want, and maybe draw something on the whiteboard that this is the kind of web page that I want. It would have these integrations. I'd like to be able to book flights from the page where it looks up many different flight providers like Finnair, Lufthansa, all the others, and then shows them in one list or something. And then it wouldn't matter if it's a design team who I'm talking to, or if it's the kind of like software engineering tools which are actually providing that. And because of this expressive power, we are losing more and more control on the bottom line and gaining lot more of expressive power. And I think that same change has to happen in testing tools as well to get to the same point. And with that change, we are slowly losing the control of the bottom level. For example, we do not test the low-level processors or the hardware in our computers to make sure that our software runs. And maybe it's at some point we don't test the actual software running on our computers to test that the actual application does what it does. And that's going to impact the kind of feedback loop that we typically have quite much. And we need faster tools in there to check out what's actually going on in there. As we are dropping, when you think about it, this is the kind of typical feedback loop that you have in testing, that you have the static checks, you have the unit tests, smoke, integration, system tests, and all the different parts in there, which actually give, the lower you go, the kind of like less feedback you actually get from the system. You get a lot of feedback from static checks that it might be not accessible to developers. And the inverse is actually true for if you're deploying the software, that you are giving more and more visibility outside of your kind of like pipeline in there to other tools, to, for example, whoever you're releasing this tool into. They see, for example, if you release a release candidate, all the people who are actually using it get more and more visibility into your code. But we are kind of like separating out a lot of these lower level checks with these tools that actually generate your code or change the whole environment in there. And that's why through all of this long overture, that's why I'm now talking to you guys about using, for example, machine vision to actually run tests and making tests more humane. Because we do not want to actually test the code. We want to actually test what the actual software does in there. And QA still kind of, in my sense, faces the most difficult problem in software, which pretty much is that figuring out what should this piece of software actually do. Not that what is in the spec or what's actually being coded, but what's the kind of human side of it, that what do I want my customers to be able to do with my website, and maybe even go one level higher, that, well, I want my customers to be able to buy plane tickets, if you're using the same example here, but actually what I want to do, deep in my heart, of course, running a business, I'd actually want the website to be also like useful to my clients, but also produce me money. So there's also a lot of these different layers on those features, that how do these actually work and what do they actually deliver. And that's something that's also creeping up a lot into these discussions, that what's the actual purpose of these features, and kind of how to test that side in there in a proper way. And kind of like what we're doing with software and programming is translating ideas to reality. And limiting factor isn't anymore the tooling and all of that, but it's pretty much our ability to imagine solutions and to express them well. If you go into your kitchen, well, I'm in a kitchen, so that's an easy reference, because my work room is taken by and I've been relegated to the kitchen by the family, so I'm going to run this in the kitchen. Anyway, for example, the microwave oven, it just didn't pop out into existence somewhere. Somebody thought that this might be a good idea, and actually from their thoughts expressed that this is something that I want to do, actually build a microwave which can then warm food and do that. It's an idea from somebody's head. And I think it's also something that Steve Jobs said, that if you look at any kind of common object anywhere, or piece of technology, it always came from the imagination of some engineer somewhere or some developer somewhere doing it. And we want to basically raise those tools into such a level that we can code more and more. So abstract this away as much as we can. Abstracting away the process infrastructure and architecture around programming and around testing as well, as you have to have both sides of those tools and be on the same kind of level. We pretty much started abstracting away infrastructure when we went to the cloud. We've abstracted away actually handling the physical service and all of that. Now we are now just assigning Docker containers to some cloud, running them on somebody else's computer, and just trusting that the actual hardware works. We are also giving away a lot of the architecture with all of these tooling that we are doing. We are abstracting away your actual system architecture to other tools, and well, we are not that far away, or we are not that far in that development than we are in the infrastructure abstraction. But slowly, that's also happening, giving a lot of the architecture out. Well, if you're building on Amazon, you have to build it on a certain way. You still have to take care of your system architecture yourself. Amazon doesn't provide you everything, but a lot of these low-code development platforms and all the others are giving you that this is the way that we want you to build architecture or build new features, and that's it. And kind of giving you the best practices, and you cannot deviate too much from those, and you don't even notice too much that the decisions made in the architecture are actually getting abstracted more and more. And that's also happening in the process side. I think process side is coming last, and this is with DevOps and DevOps pipelines, that you quite easily have codified all of that into code, and you're running it from just the coding side of it, and you're not kind of having to do it yourself. The pipeline will take care of itself. Somebody else has configured it using some kind of pipeline configuration tool, and that's also happening. But where it hasn't happened that much is then in testing and in the other places as well. So what we want to build with this is more communicability between humans and not just dumb down code. So I'm not talking about the fact that these tools would somehow make people who are excellent pro coders and all of that obsolete in any way. No, we're actually providing them with tools that offer more communicability. As I think many of you know, if there are any developers here, coding is not just about getting all of those features working. If you're working on a team, it's much more about communicating why you're doing certain things with your code, with the team, with the person who's at some point going to have to read through your code and go in and take a look at what you've been actually talking about. And maybe even yourself, if you come back a year later, it's typical, like, why did I write this bit of code and what's actually going on in here? So building these tools into the actual development side and the same into the testing side. And so how can we create this abstraction? We take technologies like machine vision and other high-level technologies into operation. I like this picture about dogs and muffins. If you just quickly look at it, it looks like that there are only muffins or only dogs, and the kind of like problem is identifying which are which. And if you train your machine learning with some images like this, you're giving it a really hard time on identifying it, because it's also a human problem identifying which is which. And this is I was talking about in the header of the talk, that we are actually making tests more human in a way. They are not anymore the kind of exact imperative and deterministic sets which test out if a certain code is in there, or if something is going on in your actual code, if some element is found out in the expat location or something like that. What we're actually doing is we're checking out the UI, we are checking out if the buttons are in there, and if through machine learning we can find the right UI elements from the right place, maybe not pixel perfect on the right place, but close enough. Of course, we can still run those kind of imperative checks and check out that everything's in pixel perfect place and all of that. But then on top of that, we want to do user level, end user level testing and end-to-end testing in a human way using machine vision. Then we are kind of separating the tests also from the actual coding implementation. So basically we are ending up with a platform agnostic testing tools which can test whatever interfaces which has also been designed to be operated by humans. And we are going to get same kind of problems as we are going to get with manual testing. And a lot of this can be solved in some different ways, but it's not always intuitive how. So one thing when you start talking about, hey, let's add machine vision to tests and start doing it that way, the first thing that at least pops into my mind is, well, aren't we just doing or making these tests super fragile because we are actually just implementing a fragile machine learning algorithm on top of it, an image recognition algorithm, which always doesn't work. Not that the test doesn't work, but the actual image recognition algorithm doesn't always work. And I think, yes, we are introducing more fragility into test cases, but then it's gonna move, I think, to the next level, which is then the platform level on handling that. So rerunning, for example, tests which have failed because some element has not been found, and rerunning the actual machine vision parts of it to figure out if those elements are actually missing, or was it an algorithmic failure on the part of the algorithm, and kind of like managing that test set based on that, and then only alerting the humans if it actually looks like, hey, we really cannot find this element from here, and this actually is a problem. And then I think another thing is that, is it actually bad that tests are slightly fragile? If you just keep on, I think this was referenced in the previous talk as well, that if you just keep on using the same tests to test the same platform, which doesn't change, you're not going to end up getting better results from there. It's just going to be a static part of the pipeline which doesn't give you any value. So kind of like sometimes inducing slight fragility into the actual testing process might actually help you go ahead and update old tests, or even remove old tests which don't provide value. And of course, if you can do that with the framework or with the tool, that you don't even have to do that kind of test optimization or test selection, then it's a much better experience for the developer to do that. And this is what I'm super interested in. How can we actually change the end-to-end testing from code-based, which we humans don't interact with code in the same way that we trigger JavaScript function or something like that. No, we click buttons and fill forms, basically. That's what we typically do in websites. So doing the same kind of thing with the same kind of approach is something that we at Copado have been doing a lot, and now it's just a little talk on what we've been building around this, and why we think this is quite interesting is that with using these approaches, I think we can increase the speed of testing quite much and increase the speed of development. We can help the quality of all the software that's happening in there, and also helping you keep in budget and helping you avoid all the service interruptions, because we are doing this kind of like more communicatable testing where you can easily talk to other team members about the test and all of that, and really like find out the problems quite easily and more easily write even these tests. And it gives you the power to clone basically your best testers and run it with the low code self-healing and AI support, giving you the kind of this level that where you're not nibbling around with actual platforms or the code underneath it, but kind of simulating these human interactions. And we've shown that it actually works quite well, for example, compared to Selenium based on that kind of approach in there. Just to give some numbers, there are better numbers if you want to, but I'm not going to bother you too much with that. But kind of, I think this kind of like platform agnostic testing will be the next big thing, and that's why at least I'm working on that field as well. So of course, a little bit of talking about what we're doing, and just to kind of actually show you some of the stuff, not just like talk about it. Let's see, I have to put the sharing off for a little bit. I don't want to switch some projects around. Here we go. Just kind of like showing actually what I'm talking about in this, but making these tests work more human and be more communicatable to humans is not just photo point. Is actually something that we are implemented in quite fast. If, for example, take our starter suite demo in here, I'm just going to launch the online editor, so it's quite easy to demo through it. So I'm talking about simplifying the test code as much as possible. Here you don't see any kind of UI selectors or XPaths or anything like that. We are actually doing the selection totally based on stuff that's actually visible on the UI. And kind of maintaining these kind of test results is I think, or test sets is much more efficient than going through, why did I have to use this really convoluted selector to get to the button that's actually in the middle of the screen? If I can just say that click the button in the middle of the screen, I think that makes a lot more sense. This is the communicability aspect. I can quite easily talk to my manager that why doesn't this fail? It actually fails on the step. It tries to click on the button that should be on the middle of the screen but isn't, and kind of giving you a much nicer discussion point on what's actually happening, and also helping you quite easily analyze what's going wrong with these tests and helping you test out. And this is all, as I said, based on machine vision. I can just show you quickly how if it loads, hopefully it loads. I've had some problems with my internet. Yeah, as said, I'm gonna have some demo effect. Interesting. Well, I'm not going to demo them, but the idea would be that I would have been able to just click on the elements, generate the actual test cases based on what I'm clicking there. It's kind of like the same way as a recorder, but not creating any kind of HTML tags or anything like that. Really creating steps based on actions that are actually happening on the screen, and kind of like this could be quite easily also read as a manual testing script. I could like get these kind of scripts and work them as an actual manual tester. And many of the like manual testing platforms also have this kind of a little bit of the same like syntax, and also a lot of other not just us, but other frameworks are also doing. For example, Gherkin and the others are also trying to humanize the way you write tests in a kind of like prosaic way as well, and kind of helping you to make it more communicatable and easier for humans to understand. Of course, there's some failure rates built into this whole thing. I think I'll still just try once in some other pursuit. It doesn't want to work with me. And now it works for some mysterious reason. But yeah. But having the actual test cases be human readable and more human-like, and having the automation be more human-like, I think helps quite a lot in actually understanding what the actual website should be doing. For example, I could shop for products, run it. I can see what the system is doing on the right side. Then I can also quite easily, with this kind of thing, just go in and interact with this browser in here, clicking on I agree. On the bottom left, you're actually generating all of these comments on what's actually happening in there. It shows you which are the right ones. And this is also something that's quite unique in the sense that we're not talking about which HTML element we're actually looking for. We actually have a totally different concept based on this machine vision side, which is basically anchoring. And it's the same way that I would explain to somebody that, for example, hey, click on the button which is on the top of the screen in the middle. This is a big red Suhan button, for example. And I would not use the, hey, it's on 100 pixels to the right and 200 pixels down. I would not use that kind of language on talking to other humans, but I could use this kind of language in the middle of the screen or next to some other object. And these are what anchors are, and then also those positional anchors, which also is changing this testing paradigm from this totally, what's the right word? Imperialistic is not the right word. Imperative test approach into the button should be on the top left, and we could click on that, or we could click on something else, and kind of the language actually in the test scripts matches the human language. And I think that this is a big thing happening now with a lot of test frameworks, that it's going to make a lot of testing more human, and through all of these new technologies, they're going to be ubiquitous. So if you don't really see machine learning or machine vision anywhere here, you're just kind of clicking on stuff, getting these kind of test scripts out of there, and that's it. It's not that difficult magic in any kind of sense, but it's just something that's changing quite fast and integrating into daily usage quite fast and changing the whole testing paradigm. This is something that I'm quite interested about, on how that is actually going on and how the development is going on. And I'd also like to hear from you guys, or anybody that help that I need, that I am interested in, is that how are you actually doing end-to-end testing? Are you about that, and what kind of approaches are you guys taking to make tests easier to create or manage, and what kind of tools actually benefit you the most on creating the most usable test cases and really helping you with your daily job, pretty much. I think that the rising to the abstraction level is one of the most powerful things that we can do in both in software engineering tools and in testing tools. And with these technologies like machine learning and machine vision, we are getting there. So thank you for listening me rant about actually how software industry is changing through machine vision and this other stuff, and how testing, I think, is becoming more and more human, because we can use now machine learning to even write the test in a different way. So hopefully that was interesting. If you have any questions, I love to talk about this stuff. So any questions?
Yeah, thanks, Henry. We love to hear you rambling about test automation. So yeah, are there any questions, or how about your own experience with test automation, or any other similar stuff? Yeah, it's your turn in the audience. Okay. So yes, Maurits, you can talk.
Okay, thanks for that. Thanks for that talk. I actually found it really quite inspiring to hear about these low code solutions that are being developed more and more. I wasn't really aware of that, and I hadn't considered either that such approaches could then indeed also have an effect on how we do testing. So thanks for that. I found that very interesting, inspiring, even, as I said. Then regarding your I'd say final suggestions, that testing should become more and more human. You give the example, click the button in the middle of the screen, right?
Yeah.
So maybe I can first say what our approach is there, and I can only say that at this point we still use selectors to do that, because how are you actually going to tell a computer where the button is in the middle of the screen if, for example, there's 4 buttons there? So I was wondering if you could maybe give a bit more of an idea on how you could teach a computer what is the button in the middle of the screen or the one that is slightly to the left of that.
Yeah, that's actually a very good point. My example maybe wasn't the best, but let's see if I can quickly dig up something that could show that. But the basic idea is that you don't talk too much about selectors. You talk about the relative placing of different visible components and like anchoring next to each other. For example, I'm just trying to find some easy example that I could show and explain it that way. The idea being that, for example, well, I'll just go to our website and show you form. Doesn't sound interesting, but it actually kind of conveys the point quite easily, I guess. Yeah. For example, in our websites, we have get a demo form, and typically when you go in, you have some form somewhere. The elements are typically quite next to each other, and if you want to have the your actual test script fill this form, for example, this is quite an easy website in the sense that there are no other form elements in here. And when you go into this as a human in this page, you look at it and you kind of, well, nowadays it's not always that easy to identify what is actually a button and what is actually a form. For example, this has also been styled a little bit, but typically you could recognize it from the input boxes as well. And I can recognize that on the left there is a form. So I could start using keywords which specify that we are actually looking for input, which is like input text, an input text into the field which has the first name text on it, and then input that in there, input text in the last name, and then if we want to, well, onto the next field, which is actually, we could say and put a different kind of anchor on there, saying that, okay, input my email into the field which is underneath the last name field. And you could kind of also work through these kind of like selectors and all of that in the same way. And I could explain it to you. And we built quite a robust system, I think, where these kind of anchors work. But I'll just quickly try to find a better example of those actually in usage. So I think there's of course the documentation, but nobody wants to just look at documentation.
It's a quite interesting example already, though, because as a human, you would basically just tab through those fields, right?
Yeah.
And you don't even care whether the first name is before the last name or the other way around, because we're so flexible in handling that.
Yeah, and that's the kind of like where I think machines are not yet there that we could like take the human kind of level analytics, but we're slowly getting there. For example, we could just say that put into the next field, put this into the next field, put this into the next field, put this, and it would hopefully work in the same way. But it's like kind of changing the, as you said, using selectors is sometimes still needed, and it's not always like always. Okay, I would have a nice. There we go. Does this one have more complex selectors? No. Well, for example, here this is a bit of a more robust test case, I guess, which is built on top of Salesforce. So we have a lot more of the kind of same selectors that I was talking about, but they are just they're not more difficult. There's just more of them. For example, here we have type text into the field first name and put in Tina in there. But then, for example, here in the type text field, we are looking for the phone field. There's actually a couple of the phone fields in the actual page. But we are saying that put this in here, and you can actually find the field next to the first name column or first name object in the actual web page. So this is the kind of anchoring that you can tell that it's next to something else, or then positional anchors as well, which kind of is a bit of a different way of thinking about this whole testing paradigm of where do you actually find pieces of UI in the screen. And kind of like not going through selectors. I guess there's somewhere in here, there's somewhere we have to touch on some of the selectors. Yeah, not really. Oh yeah, I don't have the right username and password, so of course I cannot get into the testing environment. So, let's not do that. My login has gone old. But yeah, hopefully that at least a little bit got the point on how we've thought of this and how we want to change the kind of underlying code, because that also, you don't even have to have these kind of low-code tools to get into this situation where the selectors break. You only have to have like Atom or React or some of these other front-end frameworks which generate the actual front-end IDs in breaking that. Then you need to start dealing with shadow DOMs and all of this other technical stuff, which really isn't, in a sense, hasn't got anything to do with the actual user feature that you're developing or testing in here. It's technical implementation, nitpicking on how the actual elements work. And I think the biggest question is it actually visible on the screen or not? And can a human actually interact through that feature in a way that you were thinking?
Okay, thanks, Henry. Are there any other questions?